Okay, so I'll make a start. I'll introduce myself. My name's Stephen Quinney. I work for the School of Informatics in the University of Edinburgh. Some of you have probably heard me speaking before. I got interested in security as a topic about 4 years ago. At the end of 2011, within our school we discovered we'd had a very bad root compromise of some of our systems. So that kind of got me interested. It was not something I'd ever done before, so it kind of got me interested. And one of the things I did as a response to that was to write a kind of review of all of our processes internally, of what we did right, what we did wrong, and made a series of proposals about how we could get from where we were to where we really wanted to be. That's online. You can read it. If you ever have an event like that, I heartily recommend going through exactly the same process. It's incredibly useful. I can point you to where those things are. There's talks I've done from previous years also online. So I'm particularly interested in this case about servers where you can basically get access via SSH. But most of what I'll talk about could apply to other services as well. But just to give you a feel of the angle at which I'm coming at it from is machines which are deliberately going to be public facing. So that's what I'm working with on a day-to-day basis. So I'll mention a little bit about our web servers and things, but that's not my particular area of expertise. So I might just sort of say I don't know if somebody asks a question. So I think the first thing I want everybody to kind of accept, and I've been going on about this for the last few years now, there is no such thing as a secure computer. I was reading something yesterday where somebody worked out a system where they could read the contents of memory by the heat sort of being given out by a machine. I mean, basically, you don't even need to have it networked anymore. You know, the air gap is not good enough. You know, if somebody wants that data, they will get it. So, yeah. Exactly. So you've got this problem. I'm not saying you shouldn't secure your systems. I've done previous talks where I've talked about exactly the sort of things you should be doing. You know, you should have a nice, well-defined digital fortress. You know, nice high walls, moat, drawbridge. They're great. You want them. You need them. But you have to accept the inevitable, which is screw-ups happen. Bad guys know about bugs before you do. The government knows about bugs before you do. If somebody really cares, like most of what you're being attacked by is just random kind of script kiddie type stuff. They just press a button and aim at some particular random target. But if somebody really, really wants to get into your systems, they are going to have much greater resources than you can defend against. It's inevitable. So you kind of have to, it's like a kind of Zen thing, you just have to accept that you are going to get rooted. It might be, you might be able to build defenses which mean it's not a once a year, it might become a once in a decade, once in 20 years. You know, it's like sort of the way they sort of rate floods. It's, you know, are you going to get this, you know, is this going to be, is it only going to overtop the wall once every 10 years or once every 100 years? You can build the defenses to make that risk really small, but you have to be prepared for the inevitable, which is that shit happens. You know, something is going to get into your system. The biggest weak point is your users, and that's really where you're going to suffer from. You know, if you take all the users out of the equation, life is really simple. You know, you can just say no, nobody gets onto this machine. That's where the majority of your intrusions are going to come from. As soon as you make it usable, you've got an entrance for the bad guys. That's not to say that those guys have done anything stupid. It's just they have passwords or something like that. You know, passwords are crackable. So, you know, you can give them a second factor, but you can lose a second factor. So they're the way in which they're going to get into your system. So you have to sort of think about that. So we have to be able to actually detect an intrusion when it occurs. An alarm bell needs to go off. If somebody gets into my infrastructure, something should be telling me as soon as possible. So that's what's got to happen. But there is a second thing we need to do as well. This is no good on its own, and we'll talk about that a bit more in a second. Detection is not enough. Just telling me something bad just happened, no, it doesn't really help me. I need to work out what happened and why and all that. So there is a second part to this, which is investigation. And they kind of go hand in hand, but this needs usually a lot more data. You need to collect stuff, and you need to collect stuff in advance. You can't sit down and go, the alarm bell's just gone off, what should I be collecting? You've got to have been collecting that before the alarm bells go off. So the two things are related. So that's absolutely key to this whole thing. So that's, you can't avoid that. We need to understand what the threat actually is. You need to get into the minds of how these attacks work, understand that. So, as I said, users, they're their most likely privilege escalation route. So you've got to think of that. How are they going to get into your system? If it's a web server, maybe there's a different route there. You've got to have knowledge of the system you're maintaining. So if I've got an SSH server and everything else is locked down, say that's the only port they're listening, well, that's my route in. That's how people are going to get onto the machine. They're going to go via that particular route. So you've got to know what you're managing. You can't just go, oh yeah, I've chucked fail to ban on that. It'll be fine now. I've definitely configured IP tables. It'll be fine now. That doesn't mean anything. You've got to understand what you're actually trying to protect. And this comes into the next one. What are the likely aims of the attack? Maybe it's just a script kid who just wants to do it for the hell of it. Maybe you've got really sensitive data on there that must be secure at all costs. So you've got to understand what is this attacker going to be doing. With an SSH server, maybe the first thing they're going to do is they're going to try and replace that SSH daemon with a Trojan. Because, hey, once I've replaced that, then I can gather everybody else's usernames and passwords. This is what happened to us when we had our systems rooted. The first thing they tried to do was replace the SSH daemon. Didn't actually work in that case, but it's something that immediately, somebody's trying to tamper with my SSH daemon. That's not good. It's an alarm bell. You've also got to think about how is an attacker going to actually hide themselves. Often when they've got into a system, they won't break it in such a way that it gives things away in a kind of obvious sort of thing. You won't just look at it and go, right, everything's broken. You'll be able to do an LS on the file system, and will you be able to see what they've put there? Maybe not. Maybe you won't be able to see the processes they've put on the machine. They will take various different approaches to hide things, to make it difficult for you to actually spot that they're there. They might replace the LS binary. They might replace, top or something like that. So if you type top, it never shows their processes. All of these things do happen, and they're part of a standard approach. So, whether you're on an SSH server, an Apache server, whatever, these are sort of common things. If somebody's routed your Apache server through PHP and got a shell, they can do exactly the same as if they've routed it through an SSH login. So you've got to understand that sort of what the threat is and where it's coming from. You've also got to understand how, when they get on a system from being a normal user, how do they elevate their privilege? How do they become somebody who can actually do things with your machine? As a normal user, I can't replace the SSH daemon, but root can. How do you get from normal user to super user? You've got to understand that sort of approach. The obvious way that most attacks happen is through setuid root programs. This basically means that a file, when you run it, it automatically gives whichever user calls that script root privileges. They become the super user. Now, these programs should immediately either do some authentication, authorization kind of steps through PAM or something like that, or they may actually just drop a lot of their privilege. They might just say, well, actually, you only like ping. Ping is a common setuid script. You're allowed to do one thing, ping stuff. So it drops a lot of privileges very early on. So you've got to be aware of these. But we got an attack a few years ago through the mount command. This is just by a normal user running mount. And if you run mount, it lists all the mounted file systems. Turns out the way it formats that list is locale dependent. And you can change the locale. And that in turn changes the printf strings, format strings that it was using. So you can embed whatever you like in there. So somebody had found a really weird ass locale. If you set it to that locale, they could insert like exec bin bash. And you're going, yeah, I mean, it's a failure to actually validate the data. But it's not what a root you might think, oh yeah, just running mount, I could get root that way. But these things happen. So you've got to think in terms of how they're going to get in. That was a pretty evil one, that was. Typically, once they're onto your system, they're going to use something, and rootkit is a very general term. It's like a whole, sorry, excuse me, I've got a terrible cold. It's a whole kind of bag of stuff. Often you can just download these things off the web and they'll have hundreds of different things in there that just might be useful depending on what type of attacks you're trying to carry out on a system. Typically they have BusyBox. BusyBox is great. You know, it's got every tool in the sort of sysadmin's toolbox, so it can do anything. So they don't have to rely on the binaries on your machine. They can just use their own. There may be Trojan versions of things like SSH, just there in case they want to use them. We found that they often hide bits and pieces of this in what I call plain sight. They often need to have some of the binaries in the standard path because they need to be started at boot time. So the standard path is going to be /bin/userbin/sbin/usersbin, something like that. And they'll drop something in there that looks totally innocuous. We saw ones like, I think we had a file called plog or something like that. And you can, if you did an LS of that, I mean, you will actually see it in the file system, but you would just go straight past it because it looks like a normal, you know, how many people in the room know which of the 2,000 binaries in user bin are actually legitimate? So these are things you've got to look for. Typically, these things will try to cover their tracks by inserting something into the kernel. There are various ways to do it. The most common is to insert a kernel module, which intercepts everything. So whenever you do an ls on a directory that's got the rootkit in, doesn't show it. Might just show an empty directory. Might not even be able to read the directory. Similarly with processes and all that. So this is something that pretty much all rootkits on Linux machines try to do. They try to insert a kernel module. You can actually turn that off entirely. If you never need to load kernel modules on your server, just turn it off. It's only desktop machines where you need to dynamically load kernel modules, typically. The server, you can normally go, well, I might need that one day, so I'll just load that. But we can watch for this. So these are ways in which we can set something that will set an alarm bell off if they try to do this. They often also put in kernel modules which will acquire anything that looks like sensitive data. So if it looks like a password, maybe it just kind of collects it and puts it in a file so that somebody later can log in and get all that data back. So this is kind of what the rootkit's doing, and it's going to be on your system. Some of it might be hidden, but maybe not all of it. So often things like people might be watching for is you might verify all the packages on your system and go, yeah, all the files are correct in all of the packages, but that doesn't tell you about the files which aren't owned by packages which have been put on your system. So you're kind of having to look for these things. So if we actually want to detect, oh yeah, I should say these, you probably can't see these very well from the back. Somebody has a blog of burglar alarms. It's called something like Burglar Alarm Britain or something like that. It's fantastic, and they blog a different burglar alarm every day. If you're really bored, just go and look at burglar alarms. It's hilarious. So yeah, so we need to be able to actually detect these things reliably. So given somebody can put a rootkit on your system, they can replace LS or whatever. You can't just use the tools on your system. Some people, what they do is they actually create an install on a CD, put the CD in a drive, mount the drive, and then use the tools off that because it's something that can be verified. That's quite a common one. That doesn't kind of come into this, but that's not unusual. We need to be able to monitor really important files. So that's kind of critical here. And by files, I mean files and directories. I'm using the kind of Unix files term there. So we want to be able to see not just whether they've succeeded in changing that file or inserting something in that directory. We also need to know when they failed to do it. Because your attacker might have tried 20, 30 times to do something to that SSH daemon before they succeeded. Do you want to know when they succeeded, or do you want to know that they started trying it 2 days before? It's really important here that you can see as soon as the attacks are starting. You also need to be able to monitor other resources that aren't traditional files. That's not the file system. We need to look and see what's going on with the kernel. and actually doing things like looking for system calls. So that's kind of the critical bit for the detection. This guy already said this to some extent. So we want to investigate. We need to know, critically, we need to know what, when, and who. Who is really, really important. Not because I want to go and hit somebody with a baseball bat, but just because I want to be able to disable their account the moment I know that the intrusion has come from their account. You know, that is critical. You know, I lock that account immediately, so there's nothing else they can do. So when is important. Some intrusion detection systems, I'll mention this in a minute, you might just know, oh, it happened this week. It happened today. What use is that? You know, I want to know to the minute at the very least, if not to the second, when something happened. Yeah, so we need to also have a few other things that go with this. There's no point having a record of who attempted to do something if I don't know who was logged into the machine at the time. You know, I need to know when they logged in. I want to know how long they were logged in for. Yeah, sure, some of those systems would be idle. Some of the sessions would be idle, but I need that list of who was logged in at the time, so I can see that I can kind of correlate these pieces of information. And most importantly, these log files need to be reliable. There's no point having all this data collected on the local disk and nowhere else. You know, typically when an attacker breaks into a system, they will modify your last logs, they will modify syslog, all sorts of files will just be dumped or edited. So you need some way of recording this information elsewhere, something you can trust. Get the data off the machine. So that's really important. Excuse me. So a lot of tools in the past have just taken a kind of regular file system scanning approach. All they've done is they go, right, here's what it looked like yesterday. I'm going to compare it to today. I'm going to compare the contents. I'm going to compare the mode, the group, the user. We're going to do basically just do a very complex diff. It's not that that's without use. We do it. We do it every day, just to be sure. But this is not the be-all and end-all. You need to know immediately. I'm talking about alarm bells going off the moment an intrusion starts. So things like aid. RK Hunter kind of does this a bit, which is kind of rootkit hunter. I'm not a big fan of RK Hunter. It's basically a whole bunch of shell and other stuff just kind of lumped together, and it's not very nice. So, yeah, no immediate notification. It doesn't tell you when it occurred. It just says that file changed. No record of failed attempts. No record of those 20 times that the guy over the last 2 days has been trying to break that file. So there's a window of opportunity. It doesn't matter how narrow it is, whether it's, you know, I could run this every 5 minutes, but there is always a window in which something can occur. So that's not really what I want. So what we want is real-time monitoring. I'm not selling this as the only solution. There's plenty of things out there which can hook into your system and do real-time monitoring. OSSec and things like that will do this. They tend to do it on an iNotify basis, which on Linux you've got this iNotify thing. Basically, whenever a file changes, it sends off a signal to your script saying this file just changed, and here's the details. So there are other ways to do it. I quite like the Linux Audit Daemon, mostly because it's just built in and it's there, and it can do a lot of things, far more than I can mention in this talk. We can notify immediately on important events. Now, I'm not going to talk a lot about this because it kind of involves a lot of extra work, the notification bit. But to say what you can do is you can basically, it typically will store, if you've ever kind of played with SE Linux and things like that, you'll know there's this audit.log file which you can pass through audit to allow, which you blindly throw at audit to allow until you've got something that actually lets you run your service. So again, that kind of comes back to what I was saying, well, that's not very trustable. It's on the local machine. Well, there's ways to get it off. You can actually stream to another audit daemon on a trusted host, or more simply, you can just actually stream off to syslog and get syslog remote going. So if you use something like Elasticsearch or whatever, so if you're streaming all your audit log information in real time to syslog on a remote host, that remote host can be doing all that monitoring for you and just basically flagging things up immediately. So you can use these Kibana and Logstash and stuff. You can do a lot of things with this data. So the audit framework has a plugin infrastructure. So you can basically either use the plugins that are already there, there's quite a few out on the web, or you can write your own. They're relatively simple to do, and they'll basically just take events coming in, and you can either filter them or just take the whole stream and send it off somewhere else. So you kind of build yourself a system around that. These are the critical bits for me. It records when a change occurs, and it records who made the change. And that's, we'll talk about in a second, it does it in a very reliable way. You can also record the file, failed attempts. This is important. There's no way to hide. There's no window of opportunity. If somebody even if somebody succeeds in inserting a kernel module into my running kernel, I will have had a record of them doing that. That action will be recorded. They can't go back in time to turn the auditing off before they did that.
Depending on your rules.
Sure. We'll get to it. We'll get to it in a second. So yes, it should be possible to catch the moment when these things actually happen.
Could they filter the network quickly enough that the packet hasn't got out of the system?
Probably. I mean, yes, there's always going to be a way. If somebody's really, really determined, yeah. I mean, sure, there's going to be opportunities. But, I mean, most of what this is aimed at is the 90%, 95% of attacks, which are not that good, actually. Most of the things we've seen are the kind of script kiddie level, where, the mount one I talked about, that was done through a professor's account where they'd logged in through an internet cafe in some holiday resort and picked up the username and password. It wasn't targeted in any way, just that's what happens. That's life. Sure, it's something we are looking into, but it doesn't matter. As I say, it doesn't matter. There will always be some way they can get into these things. Sorry, this screen's not great. I kind of wanted to just do this diagram off of how the kind of audit daemon all hangs together. This is actually from the SUSE website. This is just public documentation. It's a fantastic resource for all stuff on the audit daemon. It'll get you going from zero to really complex stuff. There's a URL on the bottom there, and when the slides are on the web, you could pick that up. And I think this is a great resource, and it's really nice that they've got it all online. It's better than, we use Red Hat stuff, but the SUSE documentation is definitely better for the audit daemon. So down here we have the kernel. Within the kernel there is the audit. A part of the audit framework sits inside the kernel. That's kind of critical to this, really. This is the only reason we can really trust the data, is that's where it sits. There is an audit daemon which does a lot of the work. Yes, you can kill this, but if you configure this correctly, you can get it to fall back to, say, printing to the serial console. So if everything else dies, the kernel can keep printing to serial console. You can even configure this that if the daemon dies, that it just crashes the machine on the spot. If you really care about it, you can make this thing crash the machine on pretty much anything that's going to look bad. That might be important. It might be better to have a crashed machine than a cracked machine. You've got to kind of choose where your kind of boundaries lie on these things. So I'm not going to talk about all these bits, but the main bit says this is a daemon. It will take, so an application, say SSH daemon, can send events into the kernel. The audit framework then sends out to the daemon, sends it off to a log. This is the audit daemon plugin system. So this can fire the stuff all over the place, whatever you want to do with it. And then at the back end here sits some tools, some searching and reporting tools, which you can use from the command line to actually query this information and get it into nicer sort of form. There's an audit cuttle tool, which is used to actually configure things. So this is how you create your rules, a bit like an IP tables or something. You can register rules, delete rules, change rules. And typically that takes in a file. So normally you just write your rules as a whole big file and just feed it in at the beginning, start your daemon up, and off you go. So this is the project site itself. There is a lot of documentation out there. Yep.
I was going to say, you mentioned you can fall back to logging serial console.
Uh-huh.
Can you? I believe they're going to have the net console feature where I can send it over TCP.
Yeah, I don't know. Probably. You can do anything really, but yeah, I mean that's. Yeah, it's basically just it's a fallback for when the daemon's not there anymore. So yeah, lots of documentation. A lot of it's on your system already. Some of it's better written than others. Some of it's a bit dense, and you can have to read it 3 times. But it is all there. So this is taken from Red Hat. So I'm not sure this is on every single system, but it'll be similar. So there's files. There's all the documentation on the audit daemon, the rules, the control tools. So that's the SUSE website. It's very good. So there is a lot of documentation out there. So I'm not going to try and tell you absolutely everything. It's just too much. Right, so this is, to me, this is the absolute critical element of the whole thing. It's the fact that I can trust my list of who logged into the machine and how long they were logged in for. I think without this, it all just falls to pieces. This is the problem we had when we investigated our problem, our system compromise in 2011. We had no way of proving who'd been logged on. I mean proving. We had a good idea, but we could also see that the last logs had been modified. We could see that all these different files that get used to record logins and things, they were inconsistent, and we couldn't prove whether that was because they've been tampered with or because they've just, some things aren't very good at recording this data. We had the audit daemon running, but we didn't have it configured correctly that we could actually trust the information. Now we were pretty happy in this case that it probably was generating correct information, but the attacker could have modified that data. So this is what it comes down to. There is a PAM module which needs to sit in the stack for every entry point to your system. crond, login, GDM, XDM, SSHD. Anywhere where somebody can start a new session, you need this PAM module. Preferably with this bit at the back here, this option which says require the audit daemon to be running. Don't let anybody log in if somebody's killed the audit daemon. Now, if someone's killed the audit daemon, I mean, we've been running this thing for 4 years now, I've never seen the audit daemon crash. So if it's dead, that's probably a bad sign. So don't let anybody else log in. I will know about it already, so it's already better than finding out. We were cracked for about 10 months before we discovered it. This way, I'm going to find out in 5 minutes because a user's going to phone me up and say, I can't log in anymore. So this is good. This is good. Well, the users are telling me there's a problem. And this attaches something called the login UID to the session. This is completely immutable. It doesn't matter how many times I type sudo, su, or try to change my effective UID. This login UID never changes. The thing to note there is don't put this PAM module on your su and sudo stacks because it can modify it if you actually put it into the stack. Yep.
I was going to ask, how does it ensure that immutability? I'm assuming if you restart SSHD or something, that process needs to be able to use PAM login UID, etc.
So it's basically, it's something that the Linux kernel has. There's like a kind of session, I'm not any expert on these things, but there's like a kind of session thing that's attached to you that every process you create inherits that session. So the only way you could actually do it would be to, if you SSH'd into your machine again, if you did an SSH to localhost, you could SSH as a different user, but then the login UID of that user would be recorded. And as I say, the only way you could lose it would be if you misconfigured su or sudo. So you have to be a bit careful with that. But as long as you've got it right, you will be in a situation where it doesn't matter what this person's doing. They may have become root, but every action that they execute will still have their login UID attached to it. And that's it. This is just brilliant. And, forget everything else I tell you. Do this. You don't bother with the rules. Just do this. This is so useful. Knowing who's logged on.
On the man page, it's part of the task structure and it's by child processes.
Yeah. So once you've done that, you can run this tool called AULast. I gave this talk the other week and somebody said AULast doesn't work on RHEL 7, and they're right, it doesn't. I don't know why, there's a bug. The data is there in the logs. AULast is broken, I need to file a bug about it. But what you basically get is the same idea as if you'd run last under normal circumstances. But all of this information is now trustable. That's my username. So I can now see for definite these are when my sessions ran from, days, times, whatever. So I can trust that information. And that's normally a very good way of getting the data out very quickly. It also comes with an option --proof, which kind of gives you a bit more information, and it gives you a block of information for each of those log entries so that you can then go and actually do a search. And what you actually normally use is a tool called AU search. By default, it just uses the logs that it's got on the system, but you can point it at any log files you've got. So if you're stashing them away on another machine, you can do that. So in this case, I'm just doing a really simple search. I'm just saying start on this date and time, end on this date and time, and I want this session ID. So you get as well as the login UID, you actually get a session ID as well. So everything that you've recorded that they've done within that session, it's got this tag, this session tag against it. That's quite handy. So that's often what I've done is once I've seen an event, the first thing I'll do for that event is I'll get the session ID, and then I will list everything else that I recorded for that session from beginning to end. So that's a really quick way to get around the data. AU search gives you lots of opportunities to sort of search, build searches. It's all just anded together.
Question. Mm-hmm. In the line there, you've got 3/4 of a host name, DNS name.
Yeah, it just trims it for the terminal size. It's basically just trying to be clever because it wants to make sure this information fits. So
Is the full name available?
yes, it's all in the logs. As I say, these things like AU last are really quite high-level tools just to kind of give you a quick view into the system. So really what you're going to be using most of the time is things like AU search, which give you the full access to the full data. So that's much more what you would want to use. This is it's just a really quick starting point.
This is what I was talking about yesterday, my forensics work.
Yeah.
Build a timeline.
Yeah. So a few kind of examples. So that's like a starting time, ending time, user ID. You can do a more complex search and then pipe it into AU last. There's also a tool called AU report. Some of the report, it has a whole bunch of built-in reports. Some of them are really good, some of them are just useless, as far as I'm concerned. You don't have to use it, but the login one's quite handy. And the thing to really pick up on here is there's this flag called interpret. That will convert it stores all the UIDs and GIDs and things in numeric form, but that doesn't tend to be very useful when you're trying to do a bit of an investigation. You want all the real usernames and group names and things like that. So this interpret flag will just do all that translation for you. Of course, your password file may have been messed around with, in which case that's not going to be very reliable anymore. But provided that your data is trustable, this is handy, and you've always got the login, all the UIDs and things, and the login UID there. So you can build up quite complicated searches with this. You can do loads and loads of different things. I've put this up. I'm not going to go through the whole list. Really, just to kind of go, there are some shorthand terms for when you're doing date searches. So that's quite handy there. So usually you just want to go, oh, give me everything for this week. Some of these things are locale dependent, and the number of people I've said, oh, we're using the Linux Audit Team, and the first thing they say to me is, have you been caught out by the fact that the dates are locale dependent? And yes. So by default, the locale will be C or something like that. So you'll start typing your date, whatever is it, was it 24th of the 3rd today? And you'll type it in and it'll go, there's no 3rd of the 24th. It's all because of the locale. So it tries to just interpret the dates with using its own library. So you'll get caught out if you're not careful. And things like this week, the definition of the 0th day of the week is dependent on your locale. So you may or may not get Sunday. Your guess is as good as mine. So just be aware of that. And they'll say there are all these shortcuts for searching the data. Very handy. So now let's look on to some rules. I'm not going to go through really massively complex, hairy rules because it doesn't really teach you anything. I'm trying to get to the basics of what is achievable here. There's a tool called Audit Cuttle, as I said. Typically, you set up a whole bunch of rules at the beginning before you start. When you're starting a server, they just get loaded. That's definitely the right way to do it. You don't want to be manually adding things all the time and deleting things. It just gets confusing. And you can build up really complex rule sets if you care. You can also attach labels to your recorded events, and we'll see this in a second. This is really, really handy. So you can say, if this event occurs, put this label on it, hashtag foo, whatever, So you can search for whole groups of events really, really quickly. If you just want to check for modifications or attempted modifications to your file system, this is really easy. This is what I like. This is just great. You can monitor files and directories to say whether somebody's done a read on that, whether they've done a write on it, whether they've executed it, or whether they've tried to do any attribute changes. If you would apply a rule to a directory, it applies to every directory and file recursively in the tree from that point onwards. That's quite handy. You cannot monitor root. I think that would be the route to insanity anyway. Yep.
Could you bind mount a copy of root?
I don't know. I think that would probably mess with its tiny little mind. You can monitor the individual files in this directory. You can monitor the individual directories within this directory, but you cannot set a rule on /
I try to limit the things to monitor with audit as much as possible. There is an impact.
Yeah.
Performance-wise.
So there's very little performance impact on monitoring files. When we talk about syscalls, syscalls will hammer you, and we'll talk about that in a second. Yep.
I assume that recursiveness doesn't apply to symlinks.
No, so it's done at the inode level. So that's what it's actually monitoring underneath. So when you put the other thing you do is if you monitor a directory and you've got a mount in that directory, it won't cross partition boundaries. So you would have to another monitor on that directory sort of separately. So if you're if you've got user local mounted in user, then you're going to have to monitor them both separately. It's just for sanity's sake. You don't want your kernel getting into horrid loops where it's trying to follow everything back through. So you kind of have to, this again, it comes back to knowing your system. You've got to know the layout of your file system. And you've got to know what you're actually aiming at. So this is the kind of thing we do. This isn't a complete list, but within our school, we've got a list of these. And each of these lines goes into this audit.rules file. So -w, so watch /bin. This is the -p is what we're going to, so we're going to look for write, any attempts to write or any attempts to change the attributes. And we're going to put this key, so I've got this key fs_mod. So any event which is logged from these watches here gets this key attached. So I can do a daily look. So as well as doing, say, monitoring and saying, well, an alarm bell should go off, I can actually do these things daily. I can get daily reports. Some stuff's just, there's too much noise. I don't want an alarm bell going off every 5 minutes. You'd be amazed at what applications like LibreOffice try to do every time you start them up. As a normal user, it tries to update itself in userlib or something like that. And I don't need to know that, but I do log it because just once in a blue moon, maybe it's actually a real attack. So we have these things here. We generate daily reports as well as doing these kind of immediate alarm bells. So that's how you would just search it for AU search. --key fsmod. Trivial. This is so easy, and this is really, who needs AID or RK Hunter when I've got all this stuff going on? And as I said, there is very little impact to this, but we'll talk about the way that some of the other stuff, because this is done the VFS, it's not too bad. This is very similar. This is something else. Going back to what we talked about at the beginning, privileged escalation routes. If an attacker wants to get root, they're probably going to need to run a setuid root script at some point. So here, I'm already monitoring these for writes and attribute changes. Now I'm going to monitor them for execute. And we monitor every suid script on our system. And I did a scan on my desktop the other day, and I had 44 of them on my desktop. We monitor all of them. And if anybody runs any of them. Now, that doesn't mean that an alarm bell goes off every time somebody types ping, because I don't need to know that, but I do need it for my investigation phase. If it turns out that my system's been rooted, I want to know every time somebody's used a suid script within, say, the last week. This is how we caught our mount exploit. This is exactly what we did. We said, right, we know the system's been compromised. How did they get on? Let's have a list of all the things that's happened in the last week. None of these, I can't be bothered with being told every time somebody runs mount, because actually if you use a tool like the auto mounter to do NFS mount, it runs mount all the time. So I can't deal with that load of information, but I can go and search, and I get daily reports on this sort of stuff. So if somebody's been running mount 20, 30 times a day, I'm probably going to go and ask them what they're up to. If they've run it once, well, I probably not so bothered. Yeah, that's how you can. That's what I did to find them all.
Can I ask? You said that you've been running the guy for about 10 months. What was it that actually? I know you've got this all in place now, but how did it come to your attention that that had happened?
I mean, you can read the report for the full details, but basically the system started crashing. If they eventually made it so unstable that we looked at it, and it's one of those ones of they just messed so much stuff up that eventually, you're going, no, this isn't a broken machine. This has actually got a real genuine problem. So what you can actually do as well is monitor syscalls, and you can monitor any syscall you like. Sorry, the screen's not really quite big enough for all these things. So you can basically monitor for the first bit here. You can say is either never or always. So you can actually, as well as including monitoring of syscalls, you can exclude certain ones as well. So you don't need to worry too much about that. The main thing is you get this -s and then the name of the syscall. So you can do like open, truncate, whatever. So you can monitor anything you like. The watches are actually implemented in this. When you actually define a file watch, underneath, this is what they get translated into. So you can, it's just like a quick way of getting to them, so you don't have to keep writing them all the time. You can actually combine them as well. So here I've got one rule which basically says monitor open and truncate. You can do filtering, so -f is a filter. So you can filter on things like the username, the group. So if you care about particular groups more than others, particular users, particular hosts, that's something you can do. You can also filter for success, if say you only want failures or you only want successes. And you can build these up into quite complex forms. So you can filter on things like directories. So you can basically say, I want all the opens and all the truncates in this directory. That's effectively what we saw on one of the previous slides. These examples are pretty much all in the man page. I deliberately took them from there, so you can kind of go and look them up later. So you can combine filters, you can combine the list of syscalls. So you can kind of get quite complicated and quite clever. You can apply keys, labels to these recorded events, so you can do searching for them. So that's kind of where it comes into there. So just ignore that top bit for a moment. So this is something we do. This is RHEL 6. I'm told that there are some extra syscalls on RHEL 7 that you need to monitor. We're not currently running any RHEL 7 machines, but we are running lots of RHEL 6. So under RHEL 6, you need to monitor init module and delete module. So if anybody's trying to mess around with your kernel, trying to drop modules or insert modules, this is going to trigger an event to be recorded, and I'm going to give it a label, so the -k modules. So again, I can just do a search. The gotcha here is if you're running a 64-bit architecture, then typically 32-bit support is in the kernel as well. So don't just think, oh, I can blindly put this rule in here. No, you actually need to put for both architectures. That's really important, because somebody can root you just as well in a 32-bit approach as they can do on a 64-bit approach. So you've got to get both of those rules. They cannot be combined. They have to be listed separately. So that's something to watch out for. This is what we do in terms of monitoring for events. As a kind of belt and braces approach, we actually monitor all of these. So if somebody runs rm mod or ins mod or modprobe, I know about it very quickly. Even if they manage to control-C it before it actually gets to the stage of trying to insert something into the kernel, I get to know about it. So that's really useful. So that's all. So those are just done through standard watches. As I was sort of talking about before, you can have too many syscall rules. You can make your system really, really slow, because it will check them for every single syscall you run. And it's the number of rules. So it's, as I said, one rule can monitor lots of syscalls. So combine them together, minimize the number of rules, and also if you can restrict them to certain directories, so if you, for instance, you only care about /etc, fine, filter it at that level. It will make your system much faster. You can make your system really slow with this. So that's something to be aware of. So we generate a number of reports on a daily basis, as well as all the alarm bells ringing off when bad things happen. Things like important file system changes. We actually go, although we record everything, we actually whitelist a lot of this stuff because we get so much that we kind of pick and choose about what we actually get reported on a daily basis. You know, if I get a report back that says 1,000 files, have had attempts on changing the date, I can't look through them all. So we do tend to whitelist some stuff. Similarly, set UID root. I'm not that interested about ping on a daily basis. We also get reports about kernel changes. The audit daemon will also record reboots. You wouldn't believe it, but you can have machines rebooted under your feet in the middle of the night and no one will notice. You know, the bad guys may well have just rebuilt themselves a kernel module and want to insert it, and the only way they can insert it is at boot time. So you need to know about that stuff. So reporting these things is good. When we first started, we did this with AU search and AU report, but there's actually a Python framework that's available.
The question about the ignoring changes initiated by root there. One most things that an attacker will do to try and replace binaries and so on be initiated by root, because obviously they need to have root privileges to do that.
Yeah, I mean, it's sort of what you're looking at. So we ignore some stuff that's initiated by root for say, like nightly updates. And I'm talking about reporting. I'm not talking about recording. So we record everything, but there's so much that we can't humanly process it. So we don't report on stuff that's written by root. But we run other tools on a daily basis which back that process up. And that's where things like aid and that become useful, because actually sometimes all I do care about is whether something really has genuinely changed. And it's actually quite useful. We run aid and it tells me things like, oh, you know, glibc was updated last night and all these files changed. That's actually quite handy. And we keep that as a record so that I can go back and look, 3 months ago something changed, what was it? And we've got multiple records in multiple places through different tools so we can compare stuff. So it's just about reporting. It's just dealing with the quantity of data. A few tips just to sort of finish off. You really want to enable auditing as soon as humanly possible. Well, as soon as the computer can do it. Don't wait until, normally what will happen is no auditing will happen until the daemon has begun. You can actually start collecting audit data a lot earlier. You can get the kernel to do it. It will just buffer it up until the audit daemon has actually been started and can then start logging it off. So that goes on the kernel command line. You'd have to edit your grub config to do that. That's really useful. Once you've got your configuration in place, you really don't want the attacker to be able to delete all your rules or change the rules or anything like that. So you can lock the configuration. The only thing that will unlock that configuration is a reboot. So get it right. You don't want to do it, keep rebooting underneath all the users just because your rules need slight modifications. You need to think about this. We actually, for a while, we ran in a kind of test mode where we basically had all the rules in place and we just watched them until we were happy. So we went like a month or something until we were happy that we'd stopped fiddling with it, and then we locked it. And since then we just keep them locked. So as soon as the machine's booted, they get locked. So at the end of the audit rules file, you can lock them. So you can just have that as your last thing on the audit rules file. Yeah, you probably want to log them to a remote host. Logging them to a local file system is not going to be good enough. If somebody can modify your last logs, they can modify anything else they like. They might just delete everything in var log audit or something like that, and game over. I found these really useful. Certainly on Red Hat, the RPM ships with a whole bunch of standard rule sets, which were developed by Red Hat for various sort of American sort of security standards. So there's CAP, LSPP, NIST, POM, and STIG. And you can basically look through all of those and get your ideas from them. Yep.
Now you mentioned that the SUSE docs were a lot better.
They're great.
Have you compared the rule sets?
No, I haven't, but I don't believe these were generated by Red Hat. I think they're actually a kind of like, I think NIST or something like generated them, which means there'll be NSA backdoors in there, no doubt. But you know, I believe these are standard rule sets that have been developed by other people that Red Hat just ships. They are certified. These rule sets have been certified by somebody in the US. You know, I'm not recommending them other than to look at them. They're good examples. They show you what can be done. So that's really good. There's a few limitations to be aware of. You can overwhelm the audit daemon. If you upgrade the kernel, it will start dumping stuff on the floor. If that's a really big problem, you probably want to make sure there are no users logged in whilst you're doing this. You know, you probably want to shut your machine down and bring it up in single user mode, then upgrade the kernel. You know, modifying thousands of files a second can be a problem. So if you care about that, you either need really big buffers, a really fast network, or you know, you need to do something about that. So be aware of that limitation. The syscall rules are expensive. I've said that one. AU search can be pretty awkward as soon as you're trying to do anything complicated. So we use the Python API. I basically just developed a bunch of modules on top of that, which kind of made our lives a lot easier. But that's actually quite nice to use once you get your head around it. And finally, it's not the whole story. As I said, there are other tools out there. You don't want to just be using one tool. You want to be able to correlate things and compare things. We've caught problems out because entries weren't in last, but they were in the audit rules, for instance. That tells you, well, the bad guy, maybe he's just deleted those entries because he doesn't want you to know about them. So that sort of comparison is really, really handy. So that's kind of what you've got to have in mind, is that it's good, but nothing's perfect. So make sure you've got a backup. I think that's yeah. So, and all the previous talks I've given, our big review into our system compromise in 2011 are all on this page here. I don't think I've put the slides for this might be up there, I can't remember, but they will be if they're not already. I've had a bit of a laptop crisis today, which is why I'm using a Windows machine that belongs to somebody else. So I couldn't tell you whether they're up there yet. But they certainly say they will be fairly soon. And we're a little bit over, but there's 5 minutes or so before the next talks in the other room. So if you've got some questions, we can handle a few more. If you want to run to the loo, I won't be offended.
Yeah, I know you can't give an exact figure, but roughly what sort of percentage of exploits are based on kernel module loading? The reason I ask is because we always build static kernels, so how much safer does that mean?
I think, I mean, I wouldn't recommend static kernels. We just block, because it's so easy just to turn off kernel module loading, and then it can't be re-enabled till boot time. So we literally, that's all we do. We just ins-mod a whole bunch of stuff, and then just disable kernel module loading. But nearly all rootkits will attempt to insert a module, because that is the standard way to hide process listings and file system listings. It's much simpler than trying to replace every possible binary, you know, and the fact is that, you know, if you've replaced ls, well, that doesn't help, because I can still use C to go and list a directory. You know, if I want to really fool everybody, it has to be done at the kernel level. So typically that is one of the first things they will try to do. So you really do need to be watching for attempts to insert things. You know, you can sit kind of happily going, yeah, they're never going to get me, but you need to know that they're actually trying to get you. You know, that's critical in the whole system. It's not waiting till it's...
You need to have a foothold.
Yes, exactly, because next time they might find a better way which they can get around your systems. So, yeah.
So I was going to say, in terms of sort of targeting this monitoring stuff, I mean, I guess, do you look at specific things and etc., like your pan config, your LD preload config, that kind of stuff?
We just watch the whole of it, etc. I mean, there's no reason not to. As I say, the watch rules are relatively cheap because they're done at the VFS, so they're done in the file system stuff. So it's only syscalls that are expensive.
Okay. And so, yeah, you said
so we just watch that.
You said particularly if it's a busy server,
sure, yeah, they're going to check every single syscall. Every single one is going to be checked against that table to see whether it's in the table. So it's, yeah.
I was wondering whether, like, your syslog audit log servers, whether you, I assume you probably have a couple of them at least, whether do you turn up the audit logging on those syslogs?
Yeah, obviously, yes. They need to be very powerful and able to take the load. So we tend to remote log stuff for critical machines. I mean, I wouldn't remote log a desktop machine, for instance. We have 1,000 desktop machines. I can't cope with that sort of load. But for servers, yeah, it's just kind of keeping risk. You've got your sort of risk risk profiles for your machines. So, yeah.
If you're remote logging, does that slow down the system call itself? Does it have to wait?
No. It just basically fires it off, and then that gets logged away. But it gets buffered. So as it is this problem, if there are lots of them happening at the same time, and that buffer fills, then they just start chucking them on the floor. So that's why you've got to be again. Its risk profile is if you care enough, then that's a problem. If it's just a kind of, well, the server's a bit busy today, then...
Also, you have to do both, so it can remote log and log to itself as well.
It always logs locally, yeah. So you should get most things locally. That shouldn't be too much of a problem. So was there...
What's the log format like? Is it just plain?
Terrible. It's like a binary format. You've got to use the tools. Let's say the Python tools are great for that sort of thing. If you want to really go spelunking through all the data, then you
text then? Is it like
now you're asking. I can't remember. AU Search gives you some weird-ass format, which is really hard to work with if you're using grep and awk and all those old-school tools. So they don't make it easy. It's a little bit annoying in terms of what's been sort of chucked out on the screen is designed to be humanly readable rather than humanly parsable or parsable with basic tools, which is it's a bit annoying. But there are other ways to do it, so yeah.
I was going to say, on sort of syslog servers and service log, you mentioned you can log either to syslog or to an audit daemon.
Do as many different ones as you want. You can fire off lots of plugins.
Do you have any thoughts on what is the best way, or particular preference for running these servers?
It just depends. Yeah, I don't know. I mean, the audit daemon logging can give you a lot more security if you really care. You can do things like you can actually use end-to-end Kerberos and encryption with audit daemon to audit daemon. So that's quite handy. If it's important to you, if just getting the data off the server to another machine is what you care about, then syslog will do. But if you really care about the traceability and provability of the data every stage in the process, then you need to do one daemon to another. It's all about that sort of levels of, I just want to know who the user was, whereas somebody might actually care enough that they can take somebody to court on that basis. And that's what those certified rule sets are about. It's being able to say, this person did something bad and now we're going to sue them and put them in jail. It's that, it's that sort of idea. We don't care quite that much. We're not that nasty.
I assume you can prove who's at the other end of the connection.
Sure, yeah. Right, I think we're about done because people probably need to change over. So,
Can I just
talk
about an attacker rebooting the system?
Yep.
They've got to that stage, but they reboot it with a different kernel.
Oh yeah, I mean they might well be doing that, but yeah. If you've got the moment that somebody types the reboot command, that is going to get logged to your remote server. So you've got something that says this person rebooted your machine, even if what comes up afterwards is something you can't trust anymore. You've had that event which says this has happened, and that's really what you're getting at.